Hello, class. This is Dr. Soto, and I not forgot, but I didn't want to tire you out on Thursday, but I never explained problem number 7, which you will need for your homework. And so I'm going to go over a few examples, and then if you're interested, I'll also show you why this actually works. This is off my computer, so I've already written down the problems and I've already solved them, and so I'll just explain what the question really is asking. So let's go ahead and go to the answer. So here's the basic uh, problem that you have. You want to find the derivative of the inverse at a point A. So that means you want to find the derivative of the inverse of this f function, and you want to plug the value 8 into it. The issue is that this function, if we try to do the inverse the way we were taught, first you make this into an x, and you make the x's into y's, and then try to solve, it turns out we run into major issues. It's very difficult to solve for y. And so we really can't find the inverse. And so there has to be a different way to find this inverse and the derivative. And so what we do is we actually have this nice little formula. It says that if the input is b and the output is a, then to find the inverse of the derivative, all you have to do is do the reciprocal of the derivative of f, whatever this is, and plug in the b. But again, what does this b mean? B was the input that gives you a. So we need to find out what input gives us a, and we need to find the derivative of f. And so I wrote this down as a series of steps of how you can approach this problem. Step number 1, first find the derivative of f. This is something you guys can do. You know the derivative of 5x cubed is 15x squared. You know the derivative of 3x squared is 6x. You know the derivative of 4x is 4. You know the derivative of 8 is 0. And so right here you'll see this is the derivative of f. Okay. Now comes the thing that's a little bit more difficult, but that you need. We need to know what input gives us a as an output. And so in this problem, we want to know what input gives us 8. So if we look over here, so that's what I wrote. We want to find the input b that gives us an output of a. So we set the function equal to, I'm sorry, this is supposed to be an 8. Set it equal to 8, so ignore that one. Set it equal to 8, which is right here. And when you set it equal to 8, you can do the algebra if you'd like. You said, subtract 8 from both sides. You get this nice equation over here. Sorry about the colors. You get that equation right there. And you can factor out an x. And then that means that x is 0, or the quadratic inside is 0, which is what I have. And then I can't factor that. That's not something that's easily factorable. And so what we do is we use the quadratic formula. And we notice that the inside part, this part right here, is actually equal to negative 71. So it's not a solution of this equation. Not a real solution anyway. It's an imaginary solution or a complex solution. So the only real solution is x equals 0, which means that our input is 0. Okay, so remember that our goal was to find this input b so that I can plug it into the derivative. And so now that I know what it is, now I can go ahead and say, okay, well, the derivative of f prime of b, remember, is up here. It's 15x squared plus 6x plus 4. And so when I plug in 0 in for x, I get zeros and plus 4. And so the answer is 4. And so now that I have the formula, and the formula is, again, right here, the formula that I'm using is this one. The derivative of the inverse at 8 is 1 over f prime of b, which means the derivative of the inverse of 8 is 1 over the derivative at 0, but the derivative at 0 is 4. And so we get 1/4. By the way, but that's it. That's all you have to do. But by the way, what I wanted to show you was one other thing is that right here, we went through a lot of algebra to solve this. It turns out you could use your graphing calculator to solve it, and it might be even faster. And so let me give you an idea of how I would solve this using graphing calculator. So this is desmos.com, and I type in the first function, so 5x cubed plus 3x squared plus 4x plus 8. And so it looks sort of like this. Let me zoom out a little bit. It looks like a cubic function, like any cubic function. And the second part is I want it to equal 8. And when you think about what that means, equaling 8, it means that it's a horizontal line. I want a line y equals 8 that's horizontal. And I want to know when these two lines intersect. Now notice the purple line is the y equals 8 line, the horizontal line. The green line is the cubic line. And notice that no matter how much I zoom out, they only cross at one point. And the one point they cross, which makes sense, is f is supposed to be 1 to 1. The only point they cross is at 0. And that's why we only found one solution, because f was a 1 to 1 function and it could only cross 1. So this is the reason we only found one. So I didn't have to go through this quadratic stuff, but I wanted to show you what would happen and how you'd get it. And so again, you can use the graphing calculator to find out the point where they cross. And in fact, this is going to help us with B. So this is B on your on the worksheet that we didn't go over. So here's problem number B, or letter B. So we have 2x cubed plus 6 sine x plus 4 cosine x, and we want to find out what the derivative is of the inverse of this function at a equals 4. And so this time I'm going to go ahead and graph this function. So 2x cubed plus 6 sine x. So you can kind of see what it looks like. So 2x cubed plus 6 sine x plus 4 cosine x. And notice again, it is a one-to-one function, which it's supposed to be. I mean, you can't find the inverse if it's not a one-to-one function, so it's definitely a one-to-one function. And we'd like to know, the derivative of this function, of the inverse of the f. So we want to know the derivative of the function f, but we want to know it when a is equal to 4. So we approach it the same way. Our first step, we find the derivative. I made a slight mistake here, but the derivative of 2x cubed is 6x squared. The derivative of 6 sine x is 6 cosine x, and the derivative of the 4 cosine x is the negative 4 sine x. And then, so that's the derivative. We're going to need that later. Then we want to know what input gives me an output of a. So in other words, here's the function 2x cubed plus 6 sine x, 4x. I want to know what gives me 4. And so again, here's the first function. So I already graphed it. Now I want to graph the horizontal line y equals 4. And this one, by the way, I don't know how to solve algebraically. This is why I'm doing this. I don't know how to solve this function algebraically. There might be a way, but sometimes when you can't, this is where technology really helps us. And notice they cross. They only intersect at this one point, and that one point here is when x is 0. And so from the graph, we know that the input is 0. And you can check. When you plug in 0 into the f, notice that when you plug in 0 here, you get 0. When you plug 0 into the sine x, you get 0. And when you plug in 0 into the cosine x, well, cosine of 0 is 1, so you get 4. So it really is true that when you plug in 0, you get 4. Okay. And so now we can plug in this 0 into the derivative. So the derivative is 6x squared plus cosine x plus minus 4 sine x. And when you plug in 0, again, this part is 0. The sine of 0 is 0. And so we're only left with this, and we know the cosine of 0 is 1. So we get 6. And finally, we have this formula. The derivative of the inverse at the point is just 1 over f prime of the input. And so the point that we were concerned with was 4. So it's 1 over the derivative at 0, because that's what we found, and so we get 1/6. And so this is how you can approach those problems in the WebAssign that look like this, look like problem number 7. And then if you're interested and if you have time, you can watch the rest of this video. I explain why the formula works. It's similar to what we did in class on Thursday. I have a function y, it equals f of x. That means that when I take the inverse, when we take the inverse, the y, which is the output, becomes the input. And then the x, which was the input, becomes the output. That's what it means to be an inverse. This is what we discussed on Thursday and Tuesday. And then when we use implicit differentiation, on the guy on the right, I'm going to differentiate both sides with respect to x. So I'm going to use implicit differentiation. Here I need to use the chain rule. So first I do the derivative of the outside, so the derivative of the inverse. And then I have to do the derivative of the inside, which means I get y prime. And you guys know the derivative of x, that's just 1. But remember that y equals f of x, so the derivative of y is just f prime. So I can replace the y prime here with an f prime instead. And so I get that the derivative of the inverse with your input y times the derivative of the function is equal to 1. And then you just solve for the inverse, and notice you get 1 over f prime of x. In other words, 1 over f prime of the input that you wanted to. And so this is where the formula is coming from, and this is why it works. Well, I hope this helps with your homework. If you have any other questions, feel free to send me an email. Good luck, and have a great weekend.